Hey, it's Matthew Todd and welcome to the next lesson. In this lesson, I want to talk about test levels. So far in this course, we focused on unit tests, but there are other types of tests, and indeed with these other types of tests, we can choose whether it's appropriate, whether we want to take a test-driven approach, or whether we should write these tests after the application code. So, what do we mean by test levels? What other levels of testing could we have in addition to our unit tests? So I want to start this by looking at something called the software testing ice cream cone anti-pattern. This is something some of you may have seen before, hopefully named the ice cream cone for obvious reasons, though sometimes I do worry we try and force ourselves into nice looking shapes like this a bit too much. But this describes a common anti-pattern, a common makeup of tests that many of us have, but if we thought about it, probably shouldn't have. So, what this image is showing us is the balance of different types of tests. Starting at the bottom and working up, we have a small number of unit tests. Moving up, we then have integration tests, more of these than the unit tests. I'll come back to what we mean by integration tests in a minute. And then we have automated GUI tests, again more of these than the integration tests. And finally at the top, we have a very large number of manual tests. So this image shows us the balance of how many tests we have of each different type. The idea behind this particular illustration as an anti-pattern is to show how a lot of people approach tests, sometimes deliberately, but often just through evolution of tests and development practice, perhaps looking for quick wins, which is why there might be more automated GUI tests than unit tests. I've seen many people try to get these quick testing wins for a system that's lacking any kind of tests by starting at the top, starting with trying to automate the testing of the system as a whole to encompass as much of it as possible in these new tests. There are some problems with this though, as we'll see in a minute. So if the ice cream cone describes the anti-pattern, then what do we want? So again, another commonly circulated illustration for this is what's known as the software testing pyramid, as we can see here. So this time at the bottom, we've got a very large number of automated unit tests. Moving up in the middle, we have a smaller number of API, integration or component tests. And again, I'll come on to what the middle bit looks like shortly. And at the top, we have a small number of automated GUI tests, followed by an even smaller number of manual tests. The idea being here that the manual testing we should be doing should be the exploratory testing that professional testers are so good at, rather than repeating regression testing against features in there. So all of the feature verification testing should be automated by the various automated tests towards the bottom of the pyramid. And this is the general balance of tests that people usually agree we should aim for. I don't think it's quite as simple as this, mainly in the middle area of the pyramid. I'll come on to reasons for this in a minute, but I think this is a useful generalisation and a good starting point when thinking about how to balance the different types of tests. So taking this middle section aside, if we were to look at some traits and themes we can take away from this test pyramid, we can say that as we move from the bottom to the top of the pyramid, there's more of the system involved in any given test. That's not saying we only have unit tests for part of the system. We should likely have unit tests for most individual parts of the system. But the key thing here is that in any given unit test, we should only be testing a very small part of the system in that particular test. We give ourselves test boundaries and focus the unit testing on the logical or structural units as we talked about before. At the top of the pyramid, we have the end-to-end or E2E tests for short. And these are the tests that cover all of the system, or as close to that as we can get. So if you have a complex distributed system with a front end, maybe multiple services, one or more databases in the back end, then all of these components would actually be running code and being tested by these particular tests. We wouldn't be using test doubles to provide mocks, stubs, or any kind of test double for these components and classes within them. Another thing we can say about the test pyramid, because of the scope of the system that's running code for the different types of tests, we can say that the unit tests are going to be much quicker to run, each one executing a very small amount of code, not reliant on networks, databases, or other resources that would slow down the tests. End-to-end tests, though, do involve all the components, so not only the test setup, but the test execution is likely to be much slower, typically driving a front end of some form. Also, again, because of the scope of the system involved in each type of test, As we move up the pyramid from the bottom to the top, any test failures we have are going to be much harder to debug. So when presented with a test failure in a unit test, especially when following testing for purpose, the reason for the failure should be very, very clear to us. The single piece of behaviour we're trying to verify doesn't work. So we're likely going to get a test failure with either assertion details or a call stack that's going to be very, very specific and useful to us. We're going to know very quickly from looking at the test failure details where the problem is likely to be. This is very different to any kind of failure when we bring the whole of the system under test, because there are so many failure points that could have been causing the issue. There could be networking issues, database issues, issues with the state of the system, issues with one of the services, etc. The list goes on. The failure information for the test is probably going to be the user-facing view of the problem. That is, the thing the user would see in the front end, or not see, if they were expecting some information to be present. So the failure is probably going to contain little to no information as to what part of the system actually had a problem. This would just be the user-facing view of this, but you probably don't want your users to see technical error details. And the system may also have attempted some recovery of some form. Even something as simple as rolling back a database transaction can mean that when you try and diagnose the issue, the data you want to inspect in the system may no longer be present, making troubleshooting very difficult and time-consuming. And it's for all of these reasons that we want to avoid having too many tests of this nature. I think we should think very carefully and deliberately about the balance of tests that we have, and have a test strategy that means we don't end up in a situation with a large number of brittle tests that are hard to work with. We'll talk more about this in the rest of the module, but for this lesson, I want to make sure we get the concepts of the different types of levels of testing clear. So with this pyramid, end-to-end testing should be pretty clear. We talked about exactly what we mean by a unit before as well. So the question remains what's in the middle. And this is where people often use the same terminology to describe slightly different types of tests. But basically, for the bottom of the verification is a single unit, and at the top of the pyramid is verifying everything, the whole system. Then it stands to reason that in the middle is something bigger than a single unit, but smaller than the whole system. So it could be we're testing a collection of units together. We could have a system where we have a single component that contains a bunch of units, classes, etc., and we choose to create tests for the component as a whole, only providing test doubles for where this particular component needs to talk to other components, to other parts of the system. Depending on your particular system, that could also be defined as a module, or perhaps a single service. Or maybe you have an API that uses multiple services behind it, and you want to automate the testing of the API as a whole. So my answer to what's in the middle, to what kind of tests other than unit and end-to-end tests you should create, is it depends. It depends on the specifics of the problems you're trying to solve. It depends on the architecture of your system as to how you can sensibly break it down. The types of tests you have in this middle area are going to be very, very closely tied to the design of your application, your services and how they fit together. And you also don't have to stick to just one other type of testing in this middle area. Feel free to use a mixture of different levels of testing here. The main thing that I think you should do is in your team, your organisation, you should have a consistent view, a consistently shared view on exactly what this should look like. In lesson 4, I'll cover some tools and techniques you can use to do this, and in the next lesson, I'll dig into more detail about how to choose what tests to create at each different level. So, having described the different levels of testing that we have, some of the traits that tests at these different levels have, I'll leave it here for this lesson, and I look forward to seeing you in the next one.